In this video, we're going to look at rational functions. We're going to look at the domain of the rational function, the intercepts, the vertical asymptotes, and the horizontal asymptotes. And I'm going to show a picture of each. And in this first example, we're going to look at the picture ahead of time just so we can see it and talk our way through this first one. So here in this example, we have a horizontal asymptote at 3, y is equal to 3, and a vertical asymptote at x is equal to 0. And then we have an x-intercept of 3, 0. And you can see because the vertical asymptote is right on the y-axis, there is no y-intercept. And then the domain is all real numbers except for 0 because that's where our vertical asymptote is. So now let's write this stuff out. And in the next examples, we're going to do the work and then we're going to look at the picture. So here, the first thing we're going to find is domain. And we said the domain was all real numbers except for when x was 0. So we would write that as negative infinity to 0, union 0 to infinity. And the reason that 0 is excluded from the domain is because it makes our denominator equal to 0. The next thing that we're going to find is x and y-intercepts, although we have said already that there is no y-intercept, so the x-intercept is where the function equals 0. So we have 3x minus 9 is equal to 0, and add 9 to both sides, so we have 3x is equal to 9, and divide by 3, so x is equal to 3. So our x-intercept is at the point 3, 0, which we can see in the graph. And the other thing that you have to make sure of is that if it makes the function 0, but if it makes the denominator 0 by itself, it would not be an intercept because then it would be a whole. And just be aware that we need to double check the denominator to make sure that this x value doesn't also make that 0. The next thing that we're going to find is horizontal asymptote, which I'm just going to call HA. And the horizontal asymptote you can see is 3. Now the way we find that is we look at the degrees of the independent variables, and since they're the same, we're going to take the ratio of the coefficients in front. And the coefficient in the numerator is 3, coefficient in the denominator is 1, so that gives us a horizontal asymptote at y is equal to 3. And we always write asymptotes as lines, so here the horizontal is y is equal to 3 because it's a horizontal line. And then for the vertical asymptote, it's a vertical line, so we're going to have x is equal to, and the x is going to be wherever the denominator is equal to 0 and the numerator is not equal to 0. So in this case, x is equal to 0 when x is 0, and if we were to plug 0 in the numerator, it would be negative 9. So x is equal to 0, which is represented by our dashed vertical line here. Here we have the function f of x is equal to 2x minus 3 divided by x squared minus 16. And the first thing that I'm going to do is rewrite this as 2x minus 3, and then since we have a perfect square in the denominator, I'm going to write it as x plus 4, x minus 4. And now it's easier to see where the denominator is equal to 0. So our domain is going to be everywhere except for negative 4 and 4. So negative infinity to negative 4, union negative 4 to 4, union 4 to infinity. The next thing we're going to find is the x-intercept. And when we're looking for the x-intercept, we're going to set the function equal to 0. So if we set f of x equal to 0 and we cross multiplied, we'd have 0 is equal to 2x minus 3. And now we're going to solve for x. So 2x is equal to 3 and x is equal to 3 halves. So our x-intercept is 3 halves 0. And our y-intercept is going to be where x is equal to 0. If we plug 0 in for both x's, we end up with negative 3 over negative 16, which is equal to 3/16. So we have a y-intercept of 0, 3/16. And now for our horizontal asymptote, in the last example, The degree of our independent variables was the same numerator and denominator, so we took the ratio of the coefficients. Well, here the degree in the denominator is larger than the degree in the numerator, so that means we have a horizontal asymptote at 0, so that is y is equal to 0, and then we have a vertical asymptote of x is equal to 4 and x is equal to negative 4, because those are the two places that make our denominator equal to 0 but don't make our numerator equal to 0. And now if we take a look at the picture, we can see our two vertical asymptotes at negative 4 and 4. We can see our horizontal asymptote at y is equal to 0, and then our two intercepts and the picture drawn in. In example 3, we have f of x is equal to 12x squared divided by 3x plus 5 squared. And in this problem, you have to be careful about the horizontal asymptote in this problem because it's x squared on the top and it's 3x plus 5, so we have a single x inside the parentheses, but then when you were to square it, you would end up with 9x squared. So in the early going, it might be better to multiply it out. So I'm going to show that. So we have 9x squared, and then we would have plus 30x plus 25. And now you can see that we have 12x squared and 9x squared for our leading degrees of x in the numerator and denominator. And for the domain, it's actually easier to look at the way it was written first, right? Because in order for the denominator to be equal to 0, we can just set the inside the parentheses equal to 0. So I'm going to say 3x plus 5 is equal to 0, and then 3x is equal to negative 5, and x is equal to negative 5/3. So now for domain, we know that it's all real numbers except for negative 5/3. And that's also the value that makes our denominator equal to 0, and it does not make our numerator equal to 0. So that's also going to help us with our vertical asymptote. So domain is negative infinity to negative 5/3, union negative 5/3 to infinity. And then to find the x-intercept, we're going to set f of x equal to 0. So we're going to have 0 is equal to 12x squared, and x is equal to 0. So the origin is the intercept, 0, 0. And then in this case, the y-intercept, when we make x 0, we end up with 0 over 5 squared, or 0 over 25. So it's also the origin. So in this case, we only had one intercept. The x and the y-intercept both gave us 0, 0. And then our horizontal asymptote, we have the same degrees in the numerator and denominator, so it's the ratio of the coefficients, 12/9, or we could write that as y is equal to 4/3. And then the vertical asymptote we already talked about, and that was x is equal to negative 5/3. And in the picture you can see that drawn out. And that's all for this video on rational functions.